Okay, so today we are going to be adding and subtracting radicals, and I relate these directly to how you dealt with like terms and with variables, and then also how you add and subtract fractions. So just a quick reminder, when you are simplifying a radical, so let's say for example we have the square root of 72, and we are wanting to simplify that. That is the same thing as the square root of 8 times the square root of 9. And square root of 8 is the same thing as the square root of 4 times the square root of 2. And square root of 9 I know is 3. Square root of 4 I know is 2. So these are all outside the radical. And that 2 is the only thing that is left under the radical. Another way that I showed this was to do the prime factorization of 72. So we have 8 times 9. 8 breaks down to 2 times 2 times 2. 9 breaks down to 3 times 3. So I have a pair of 3's and a pair of 2's. So I take one number from each pair out. So I have a 2 times a 3. So there's my 2 and there's my 3. Then anything that is not circled gets multiplied and put back under the radical. And you're right back to 6 radical 2. So either way is perfectly fine. Just make sure that you are showing me your thinking so that I can follow your work. Okay, so we're going to actually start adding and subtracting radicals. And like I said, it reminds me a lot of just simply adding like terms. So if we have 3 x's and we add 4 x's to it, we now have 7 x's. The x's, that's a whole reason why we can add them, is because they are like terms. So because they are like terms, this does not change. We have 3 xylophones plus 4 xylophones equals 7 xylophones. Also with fractions. As of right now, we cannot add those because we do not have a common denominator. So when we get a common denominator of 6, that means that this is going to be something over 6 plus something over 6. So I multiplied the 2 times a 3 to get 6. So I multiplied the 1 times the 3 and get 3 6. 3 to a 6, I had to multiply by 2. Multiplied this by 2 as well. Again, the whole reason why we did this is to keep the denominator. If we didn't have to keep the denominator and we can just add them, then we could have just added these, which is not true. Okay, so let's start our radical examples. So example 1, we have 2 radical 3 plus 5 radical 3. These are like terms because they has the same number under the radical, square root of 3. So if I have 2 square root of 3's plus 5 square root of 3's, that gives me 7 square root of 3's. Notice it stayed the same. It did not change. Example 2. We have negative the square root of 5 minus 7 the square root of 5. So looking at this scenario, what did we do when we had just simply an x? So if we had x minus 4x. Remember, that was the same thing as having an understood 1 there. So this is no different. There's an understood 1. So you are combining the numbers that are outside the radicals. So negative 1 minus 7 gives me a negative 8. And then they are like terms. We keep the radical. So negative 8, radical 5. Example 3, negative 7 radical 3 plus 7 radical 2. So I'm looking at this one and saying, well, the 7's are the same, but we need to be focusing on the number under the radical. I have a square root of 3. I have a square root of 2. 3 cannot break down anymore. There's no perfect squares hidden in there. 2 is just 1 times 2, so there's no pairs hidden in there. There's nothing I can do with this. So this is my final answer. It'd be no different than having like negative 7x plus 7y. We can't combine them. They're not like terms. They don't have the same variables. Example 4. Square root of 45 plus 8 radical 5. Excuse me. So at first glance, we look at this, and first of all, we know if there's a 1 there, understood 1. First glance, it looks like they cannot be combined because they do not have the same number under the radical. You always have to simplify. And I know that the square root of 45 breaks down to 5 times 9. Bring down the 5. 9 breaks into 3 times 3. So there's my pairs. Take one of those out. Times my 5. I have a 1 outside. Times my 3 outside still gives me the 3. I bring down my 8 radical 5. So now I have 3 radical 5s plus 8 radical 5s. They are like terms because they have the same number under the radical. And so you get 11 radical 5s. Last example, I'm just going to move it over here. We have 3 radical 27 minus 2 radical 108. A little bit bigger number. Keep in mind, if you had to, in another previous problem, find the square root of 27, then you don't need to do it again. You can just take that work from the previous problem. So the square root of 27 is 3 times 3 times 3. So there's my pair. And so that means I take 1 out, and the garbage left is the square root of 3. So this is where, be careful, the square root of 27 is 3 radical 3. Now remember, there's an understood multiplication going on between the 3 and the radical 3. There's not an addition or a subtraction sign. But we already have a 3 outside. So this is actually times the 3 that I already have there. Okay, so the square root of 27 is being replaced with a simplified 3 radical 3. But you can't forget about the 3 that you already have. So that means I end up with 9 radical 3. So I have to multiply those two numbers. And I'm going to do the same thing with 108. So 108, I know, is 12 times 9. And there's a pair. And I know 12 is 2 times 2 times 3. I have a pair of 3s and a pair of 2s. Take one number out from each pair, and I get 6. Garbage left is radical 3. So again, the square root of 108 is 6 radical 3. Don't forget about this negative 2 that you have here. Remember, it's multiplication. So you end up with 9 radical 3 minus 12 radical 3. Now I have the same number under the radical. And 9 minus 12 gives me a negative 3. And then I have the square root of 3 left over. So that is how you simplify radicals, by adding and subtracting radicals.